Hello and welcome back. So in our journey towards mastering agents and ADK, we're going to explore a very important concept, and that is function calling. When it comes to Gemini, there are three techniques to call a function. One is a multi-turn manual mechanism. The second one is API-driven automated function calling. Third one is very interesting, which is MCP or Model Context Protocol based function calling. So in this session, we're going to explore all the three techniques. Let's get started. So let's understand how function calling actually works. So there is an application. This could be your chatbot or even a Jupyter notebook or a console application that is invoking Gemini. So you send the prompt along with the function definition. Now this goes to Gemini and Gemini decides what to respond. In the first step, it is going to figure out the function and the arguments that you need to invoke. So that's what comes back as the completion, which is step 1. In step 2, we extract the function name and all the arguments as identified by Gemini in step 1. And once we identify and extract the arguments, we go ahead and execute the function. And this function is typically a part of the same code base. If it is an API, we're going to wrap it in another function, but essentially this is a function that is callable. Now that is step 2. So we invoke the function and we send the result of the function call back to Gemini along with the original prompt. Now Gemini has the context to respond based on the original prompt that we have constructed here. So in the final step, it is going to take the prompt plus the output of the function call and comes back with the final answer. And that's what is step 3. So there are 3 steps and there are 3 turns essentially in this approach. Turn 1 is invoking Gemini with the prompt and the function definition. Turn 2 is extracting the function call and the arguments. And turn 3 is basically calling Gemini again with the output from the function. And finally, showing the output of the final response to the user. So let's see this in action. In the next demo, I'll walk you through how to perform this multi-turn based function calling using the same steps that we are seeing in this slide. All right, so here is the first demo. We start by importing the modules and then we define a function. So for this demo, I have taken an extremely simple example of getting the temperature of a specific city. Now this is almost like the hello world of function calling. And in most of these scenarios, you would actually see the get temperature function. So this is going to be the definition and it contains the JSON description exactly how it is defined here, which is the next step, the function implementation. So the function name is called get current temperature. It takes location, which is string. That's what we define here. And it returns a dictionary. So again, that is what is defined here. So this is the signature and this is the actual implementation. And to keep this simple, we always send 27 degrees Celsius as the temperature. So let's execute that. And then in the next step, we basically initialize the client. So when we are initializing the client, you're already familiar with these 2 steps. If not, refer to my previous videos of this series. We are basically we are instantiating the client object and then we are defining the tools here. And when we are doing that, we pass the get temperature function, which is basically the dictionary which contains all these key value pairs here. So we pass that and then we have the generate content config and that's accepting the tools. So this is the configuration parameter sent to the model and this contains all the tools that we define. Now, if you have more than one function, it's absolutely fine to include that in this list. But for this sample, we only have one and only one function. So let's execute this. So remember, the first step, which is turn 1, is all about invoking the model with the prompt plus the function definition. That's exactly what we are doing here. The user message, which is basically defined here. What is the temperature in London? And then it comes back with, it then defines the actual response where we invoke the generate content we pass the user message, and we pass the configuration which contains the tool. So let's execute this. Now this is the first step takes place, and then this is where the heavy lifting happens. Now the function call that we are going to extract is coming back as the output from the initial turn 1 invocation. So we access that, and then if function call is not null or not empty, we extract the function to call and the arguments. Then we go ahead and execute the function. So in this case, because we only have one function, we are going ahead and executing that and passing the arguments as identified by Gemini. Now in our case, the argument is going to be London because Gemini will identify this as one of the potential parameters. In fact, the only parameter. So we invoke that with the identified parameter, and then we call the model again, this time with the actual function. So this is where you have the final step where we invoke the model again with the user message, the function call from turn 2, and the response from turn 3. And finally, we print the output. So this is pretty straightforward. We will initially extract the function name and the arguments, invoke the function, and then pass the output of that function as another parameter to Gemini. So let's go ahead and execute this. So the function to call has been identified as get current temperature, location is London, and the final response is the current temperature in London is 27 degrees Celsius. That's because the function is always returning temperature in Celsius as 27. So that is the multi-turn example of function calling. This is the manual mechanism where you have complete control. In the next demo, I'll show you how to do this with automated function calling where the API does the heavy lifting. Stay tuned. All right. So in this demo, we'll see how to do the same thing that we have done earlier, but with automated function call. So we first import the modules, then we implement exactly the same function, get current temperature, and then we will initialize the client, and here we will wire the function. So wiring the function is directly creating the get temperature, get current temperature function. And notice that we are not defining that as a dictionary. Instead, we are directly sending the function name to the API. So we wire this to the API, and then we'll invoke the API directly. And this time we have the content, which is the prompt that says what's the temperature in London, and then the configuration. Configuration contains the function name that the API can invoke directly. That is the SDK. So now it is saying fetching temperature for London, and then we can print the output. Ignore the warning, but you can see that it is coming back exactly with the same output. Now this is a very simple and straightforward mechanism for function calling or tool invocation based on the Python SDK of Gemini. So this makes it extremely simple and straightforward to wire as many functions as possible. Of course, there is a limit to how many you can, but you can always send multiple functions directly without first defining the signatures or the definitions and wiring it up with the API. So that's the second demo. In the next demo, I'll show you how to do this first with automated function calling, and then we'll take a closer look at MCP. Stay tuned. So in the previous two demos, we have seen a dummy function and invoking it. Now I want to introduce you to something more real world and a practical example. So what if you are able to ask Gemini about the current flight status? For example, one of my favorite flights, which is EK226 from San Francisco to Dubai, and I want to get the current status of this flight. Now, as you can imagine, Gemini by default doesn't have access to the flight API or the flight schedules. So we are going to write a function, send it as a tool to make sure that Gemini has enough context to respond with real-time data. Now, in order to take advantage of this, I'm going to consume an API called FlightAware API. You can go to flightaware.com and sign up for this. It's free, and all you have to do is sign up and grab the API key. So I have already signed up and got the API key. So I'm going to use that to basically create a function that extracts the current flight schedule and then passes that along to Gemini for invocation. Let's see. First step is we are going to import all the modules, and then we are going to implement the function. So this is where we are defining the function that invokes the Aero API. So I'm getting the Aero API key from the environment, the operating system environment variable. And then we basically call the function called fetch flight data. And what I do is I convert the start date and end date and the time into local time zone wherever it lands. And I also wrote a helper function which is UTC to local, which will help me get exactly the time based on its source and destination. And finally, I send the complete data, which is acting as context, which is flight, the source, destination, departure time, arrival time, and the current status. So that's what is the function. It is basically a wrapper for the FlightAware API. And then we will initialize the client. So then we will go ahead and wire it up with the API by using the configuration section. And then all we have to do is invoke Gemini by passing the prompt and the config. So I'm asking about the status of flight, which is Emirates EK226, and then we'll access the output. So now it comes back, it says EK226 from San Francisco to Dubai is currently en route, on time. It departed on 8th July at 5:05 and is expected to arrive at 7:12 p.m. on 9th of July. Perfect. So this is real-time status and real-time data which is coming from the FlightAware API. So this is a practical example of how you can use tool invocation to pass additional context to Gemini and enable it to come back with accurate and factually correct answers. So these three demos demonstrated or showed you how you can use tool invocation. But Gemini out of the box supports MCP or Model Context Protocol. In the next demo, I'll show you how we can create a very simple MCP server and then use Gemini API to directly invoke the streamable HTTP MCP server. Stay tuned. All right, let's get started with MCP. So what you see here is a very friendly library for MCP called FastMCP. I am currently writing this server and we are calling this as employee server. And this basically sends a static list of employees and their roles. So we have this function called getEmployees and we simply annotate that with MCP tool. Now this is basically an indication that this function is acting as an MCP tool. And here we have a dictionary, we have an identifier, name, and the role. And when we run this MCP server, we are defining the transport as streamable HTTP. Now this can be by default STDIO, or for backward compatibility, you can set it to SSC, the server-side event. So you can use one of that, but I prefer streamable HTTP, which is very powerful because you can have multiple clients talk to the same endpoint. Now, once we have the server defined here, the MCP server, the next step is wiring it up and invoking it through Gemini. So here we are using the native MCP client and we are importing the streamable HTTP client. So we are setting the MCP server URL to the local host and /MCP designates the streamable HTTP endpoint. And then we'll go ahead and create the Gemini client, which is this. And then everything is asynchronous. So we first start a client session based on the streamable HTTP client. And then within the session, we are going to send a prompt to the model. And the prompt is who is the intern in the company. And then we are basically invoking Gemini 2.5 Flash and we are sending the configuration as the session. So within tools, we are not really including a function, but we are sending this session. And the session is already pointed to the HTTP streamable endpoint. And that will basically discover what are the available tools and automatically invoke the appropriate tool. Now, this is an extremely simplified example, but you get the idea. So we are passing the MCP session as a tool instead of the native function defined within the same code base. So let's go ahead and run this and see how it actually works. So in this step, I'm going to run the server. First, we'll run the server. Now, when the server runs, you can see some output on the console. It's called employee server. It's available on the URL, which is localhost 8000 MCP, and it is currently listening on port 8000. Perfect. So now with the server up and running, let's invoke the client. So when we invoke the client, you'll see some logs being printed. First, it is accessing the MCP endpoint, and then it does get and a couple of posts, and finally it comes back with the response. Now ignore the warning, but we asked who is the intern in the company, and it says Eve is the intern. Let's verify this. So we'll go back to the static list, and indeed Eve has the role intern. So that is how you invoke MCP natively from Gemini API. This is extremely powerful, and we are going to expand on this concept and idea when we look at agents. This forms one of the core building blocks of building agents from the scratch. So that brings us to the end of this session, where we explored function calling or tool invocation, and we looked at all the mechanisms that Gemini natively supports. This completes an important milestone, which is the fundamentals of Gemini. Starting the next module, I'm going to talk to you about agents. So the next session, I'm going to introduce how do you visualize agents, how do you define agents, and how do we get started with agents. Before we get to code, I want to make sure you get the intuition for AI agents, and that's what I'm going to cover in the next session. So if you haven't subscribed, please subscribe, like, and share my video. That will help me reach more audiences. Thanks once again, and I'm going to bring you the latest and up-to-date content.